Hello everyone, welcome to the next section, Recurrent Neural Networks. This section covers the RNN concept and a complete depiction of all the stages of the most used architecture, the LSTM. Finally, in the last video, a practical exercise in time series prediction is shared. Now we move on to the first video of this section, RNNs. In this video, we are going to learn about RNN, look at its type, development, and the main problems. So what do you think is RNN? RNNs are artificial neural network (ANN) models whose inputs and outputs are sequences. RNNs are highly expressive and can implement an arbitrary memory-bounded computation, and as a result they can be configured to achieve non-trivial performance on difficult sequence tasks. Types of sequence to be modeled. RNNs work with sequences models, both in the input and the output realm. Based on this, we can have all the possible combinations like one-to-one, one-to-many, many-to-one, and many-to-many. The origin of RNNs is surprisingly common to the other modern neural network architectures, dating back to Hopefield networks from the 1980s. The figure shown here is the common structure for the first iterations of the recurrent architecture. Classic RNN nodes have recurrent connections to themselves, and so they can evolve their weights as the input sequence progresses. Additionally, on the right of the diagram, you can see how the network can be unrolled to generate a set of outputs based on the stochastic model it has saved internally. It stores representations of recent input events in the form of activation. However, RNNs have turned out to be difficult to train, especially on problems with complicated long-range temporal structures. Since their potential has not been realized, methods that address the difficulty of training RNNs are of great importance. One of the main problems with RNNs happens in the backpropagation stage. Given its recurrent nature, the number of steps that the backpropagation of the errors has corresponds to a very deep network. This cascade of gradient calculations could lead to a very significant value in the last stages, or on the contrary to ever-increasing and unbounded parameters. Those phenomena receive the name of vanishing and exploding gradients. This is one of the reasons for which LSTM was created.